So depends on kind of, one, how long the fast is, and two, what we're trying to accomplish. Time restricted feeding is when we restrict the feeding window. So you eat for 8 hours in a day instead of just grazing all day. So that's our 16-8, or even the OMAD, which is the 1 meal a day. That to me is a time restricted feeding, and that's how some of the research properly terms things. Other times they just call all the intermittent fasting, okay? In my definitions, intermittent fasting is when we're doing something for longer than 24 hours, okay? So we're going a full circadian rhythm cycle of fasting or longer. So here, isocaloric, so same amount of calories between the two groups. What they did was the control group, they allowed them the 12 hours to eat. So that's your normal, eat at 8 o'clock in the morning, eat at 8 o'clock for bed. And then the other one, they restricted it to 6 hours. This here was the first randomized control trial to actually look at the impacts on circadian clock genes. Remember, we're tying this back in with stem cell function here. Glucose, brain-derived neurotropic factor, 24-hour glucose, genes associated with autophagy, and some other hormones. The two big things they found that are clinically relevant to what we're going to talk about today is, with the fasting group, they saw a decrease in evening cortisol and an increase in morning cortisol. Better circadian rhythm. Yes, Teddy?
Sorry, I missed a question on Facebook.
Oh, it's okay.
If you only like...
Right, that helps to ingrain the circadian rhythm, being awake in the morning, asleep at night. With that, they saw an increase in the actual genes in autophagy, which I found was super interesting. Now, go back one here. So, if you look here, this is a little flipped on what most people will do with time-restricted feeding. Most people will wake up in the morning, they'll keep fasting until their 18 hours or their 16 hours is up, and then they'll eat until bedtime, and then they will look at, and then they'll restart, right? This one was flipped, so they did breakfast, lunch, and their dinner, but their dinner was at 2 o'clock, and then they did 18 hours. So they ate in the morning, and they fasted at night. Important. When we look at the genetic changes, the fold change for one of the genes for autophagy, you notice that it was actually increased in the morning, which initially might seem counterintuitive because they ate in the morning, but they ate in the morning after fasting. And the genetic changes take some time because you have to have the stimulus to go to the nucleus to make RNA, the RNA to then become expressed and actually show a change. They didn't see the change in the evening because the microenvironment that sets up this genetic expression was food. The microenvironment that sets up this genetic expression was fasting. Guys follow? Margie?
I got it.
Okay.
Yeah.
So this shows us that autophagy, one, we want this cycling. A lot of the research is showing we don't want autophagy all the time. Okay? If you chemically induce autophagy with a drug like rapamycin, which is a chemotherapeutic drug that's now being studied for longevity, if you do too much rapamycin for too long, it's very harmful to the animal, the human, because it's too much autophagy. You eat up way too much stuff. The opposite of autophagy is mTOR, which is our anabolic processes, okay? Too much of that is what a lot of people believe has led us to this health crisis that we're in, which is obesity, diabetes, cardiovascular disease, that kind of stuff. So this cycling of autophagy and autophagy is important, but this also shows us that we can have changes in autophagy after short periods of time. Yes, Teddy?
Sheil asks, what are your food suggestions for the first meal after fasting hours?
So depends on kind of one, how long the fast is, and two, what we're trying to accomplish. So in terms of the length, if it is a 16-hour fast or an 18-hour fast, basically anything less than 24 hours, usually it's not a big issue on what the patient's eating, because we are constricting our meals down. We do tend to see a slight reduction in caloric intake in patients. So if they were to graze naturally, they might consume 2,500 calories. With a 6-hour feeding window, they might only be able to consume 2,000 calories. And so I want them to focus on nutrient-dense food. I don't want them getting 1,000 calories from junk food, because then that only leaves them with 1,000 calories for nutritious food. Whereas if they weren't fasting, they might have gotten 1,500 from nutritious food. And so we might be losing on that side. If we are doing a longer fast, 36 hours, 72 hours, usually I'm going to have patients break the fast with something a little easier on the stomach, usually a collagen-based or a bone broth or a soup of some sort. That's going to be lower in fiber content, typically a little lower in the hard-to-digest meats, just because the stomach has kind of been asleep for quite some time, and we want to prime it a little bit with some other food. So usually, and then I think always I tend to try to have patients do lower carbohydrate for that first meal as well, because insulin sensitivity temporarily goes up when we're fasting, and I don't want them to eat sugar and have this big insulin spike and then crash afterwards as well, okay? Here are a whole bunch of different things that in some human studies and some animal studies we see happens with fasting, okay? The green arrows are the things that are going to be clinically important for our understanding of healing and pain and things like that. Decreased inflammatory cytokines, reduced inflammation in the GI tract, reduced glucose, insulin, and leptin levels, increased adiponectin, which I didn't put an arrow there for. We're going to see positive changes in adipose tissue, increased sensitivity to insulin in the muscle. Again, all these things that are happening on a systemic level because we are introducing a stimulus which is creating a systemic-wide change.